Hello, in this video, we're focusing on the practical concepts that you can actually apply in the real business world. Hope you enjoy it. Let's get on with it. Today, we're looking at supply chains, which are some of the most complex systems businesses manage. They involve many locations, suppliers, logistics, factories, and customers, all producing a huge amount of data and constantly facing interruptions like pandemics, political issues, labor shortages, and climate challenges. These disruptions have shown that traditional supply chain tools often fall short because they rely on static models and past data. To address this, more companies are turning to digital twin strategies. A digital twin is a live virtual model of a physical system that updates in real time to match what's happening on the ground. In supply chains, this means businesses can simulate different scenarios, test decisions before acting, and improve overall efficiency and resilience. This presentation will explain what supply chain digital twins are, how they add value, steps to implement them, real-world examples, and the pros and cons of using this technology. Essentially, supply chain digital twin combines data from many sources like ERP systems, IoT sensors, transportation tracking, supplier platforms, and external data feeds into one connected and dynamic simulation that closely mirrors the real operations almost instantly. A digital twin stands apart from traditional planning models because it is dynamic and constantly updated rather than periodic and static. It uses analytics and simulation to be predictive, enabling scenario-based what-if analysis. This approach supports both operational and strategic decision-making. Rather than just showing a static image of the supply chain, a digital twin allows leaders to test changes and observe their effects before implementing them in the real world. One of its key business values is providing end-to-end visibility by integrating data from suppliers, manufacturing, distribution, and customers into a single, clear view. This reduces blind spots, speeds up issue detection, and improves coordination across different functions, which is crucial for resilience and performance. It also helps with scenario planning and risk management by allowing organizations to simulate disruptions like supplier failures, port congestion, demand spikes, or transport interruptions. Leaders can evaluate impacts such as losing a critical supplier, finding alternate logistics routes, or repositioning inventory, enabling more proactive responses to challenges rather than reactive ones. By combining demand data, market signals, and real-time operational limits, digital twins enhance forecast accuracy and help balance supply with demand more effectively. This results in fewer stockouts and overstocks, reduces the need for excess working capital, and improves service levels. The digital twin isn't static. It learns and adapts as conditions change. On the operational side, they let businesses test decisions like production scheduling, transportation options, and warehouse layouts without interrupting daily operations. This ongoing optimization lowers logistics costs, boosts throughput, and allows better use of resources, making optimization a continuous activity instead of a one-time event. Strategically, digital twins provide support for major decisions, such as redesigning supply networks, diversifying suppliers, planning capital investments, and advancing sustainability efforts like reducing carbon footprints. This data-driven insight gives executives greater confidence when making important, high-impact choices. Implementing a digital twin is more than just an IT project. It's a strategic transformation that requires several important steps to succeed. First, it's crucial to define the business objective by understanding why the digital twin is being developed. Common goals include improving supply chain resilience, cutting operating costs, raising service levels, or enabling quicker decision-making. Having clear objectives helps avoid overcomplicating the project and keeps the scope focused. Next, you need to map out the physical supply chain in detail. This means documenting all key elements like suppliers and their tier 2 relationships, manufacturing sites and their capacities, warehouses, distribution centers, transportation routes, and inventory policies. This comprehensive mapping forms the backbone of the digital twin model. Finally, data integration is the most critical and challenging part of the process. It involves bringing together data from various sources such as ERP and planning systems, IoT devices used in production and logistics, supplier data feeds, customer demand signals, and external information like weather or geopolitical risks. Successfully combining these data streams ensures the digital twin accurately reflects real-world conditions and drives better insights. Ensuring data quality and strong governance is crucial to maintain reliability throughout the digital twin. Once the data flows are in place, the next step is to develop the simulation and analytics layer, which models how the supply chain operates under various conditions. This includes discrete events, simulations, optimization algorithms, machine learning for predictions, and constraint-based planning. It's important that the model is realistic enough to be useful, but also easy to use. Then visualization and decision support tools help present insights clearly through dashboards, alerts, and scenario comparisons, enabling decision makers to understand results quickly and act with confidence. User adoption depends on how clear the information is, not its complexity. Finally, digital twins should not stay static. They should evolve. Many organizations start small, focusing on one region or product, and expand over time as they see the value. Continuous updates and refinements ensure a strong return on investment. For instance, a global manufacturing company used a digital twin to handle demand variability across different regions. By simulating different inventory and production scenarios, they managed to reduce service disruptions, improve forecast accuracy, and lower the amount of safety stock needed. This example shows how practical application of a digital twin can create real benefits. To give you a clearer picture, here are some examples of how companies have benefited from digital twin technology. A logistics provider used it to model warehouse and transportation operations, testing different routes and staffing plans before making changes, which led to faster deliveries and higher throughput. Another example is a global consumer goods company that simulated supplier disruptions and geopolitical risks. This helped them react quickly during major global events by finding alternative sources, which kept their products on the shelves and ahead of competitors. The main advantages of this strategy include real-time visibility across the entire supply chain, proactive risk management, data-driven decisions, cost reductions, improved resilience and agility, better collaboration across departments, and more effective long-term planning. When properly implemented, digital twins offer a strong competitive edge. That said, there are challenges to consider, such as the high initial cost of building these models, which can be a barrier for smaller companies, and the complexity of integrating diverse data sources, especially when data quality isn't optimal. Managing these complexities requires careful planning and investment, but addressing them is essential to realize the full benefits of digital twin technology. Successfully adopting digital twins depends on having strong collaboration across different teams and a solid analytical skill set. Sometimes resistance to making decisions based on data can slow down or block this process. It's important to remember that digital twins are simulations. They're valuable tools, but they don't perfectly replicate reality. Relying too much on the models without applying human judgment can lead to less effective decisions. Overall, the shift to using digital twins represents a major change in how companies manage their supply chains. By creating virtual models that reflect real-world operations, businesses can gain better visibility, predict future issues, and make smarter decisions. In today's fast-changing environment, these abilities are not optional, they're essential. While setting up digital twins takes investment, good data, and organizational changes, the advantages far outweigh the costs, especially for complex supply networks. Used thoughtfully, digital twins help companies not just respond to changes, but anticipate them, positioning leaders ahead of those who lag in resilience and operational excellence. If you found this video useful, there's plenty of more business and finance videos on the channel that you'll enjoy watching and get great practical value from. In the meantime, thanks for watching.